All right, so this is Energy and Machines additional problem number 12. And it says Tom's favorite pastime is fishing. They want to know how much work is required for Tom to reel in a 10-kilogram bluefish. So there's a fish down here. Here's my pretty picture of a fish, and he's blue. Get it? He's blue. It's a bluefish. And he's way down here below the water, and he is attached. And we know that the mass of this fish is 10 kilograms. And it says that I need to pull him up 5.2 meters. So he's really deep within the ocean. So 5.2 meters, that is my distance or my height, depending on what I'm trying to do. And we know that his fishing pole, the efficiency of his fishing pole is 85%, which in decimal form would be 0.85. Now I think we have everything we need in order to solve this. They want to know how much work is needed in order to reel this fish in. We already have all of the things that we really need. We know that efficiency is equal to the force out times the distance out over the force in times the distance in. That is another way of finding efficiency. If I rearrange the equation, I can say the force in times the distance in is equal to the force out times the distance out divided by the efficiency. Remember, force times distance, so force times distance is work, so we're finding how much work it took for him to reel this fish in. Our force out in this problem has got to be the mass of the fish, so there's the mass of the fish there, times, remember we got to use gravity, so this is the mass of the fish times gravity, which is 10, and then the distance that we have to have that fish go, and that was the 5.2 meters. We need to divide it by the efficiency. We can't use the percentage, so we're going to use 0.85. When you solve then for the work, you should end up with 612 joules. So I'm sorry, that's the that's the work that it takes in order to reel the fish in. So that's part A. For part B, they want us to find what is the actual mechanical advantage. If the force out is 100, so the force out is 100 newtons, and the force in would be 15. The force out is really just the mass of the fish times gravity, and that's divided by the force in, and they tell us that the force in is 15, and that comes from the fishing pole itself. So let's plug everything in. We're going to have 100 on the top. We're going to have on the bottom 15, and when you divide the two, you end up with an actual mechanical advantage of 6.7. The last thing they want us to do is find, for letter C, the ideal mechanical advantage. And ideal mechanical advantage is easy to find. We can just say it's the actual mechanical advantage divided by the efficiency, because remember, efficiency is AMA over IMA. Our actual mechanical advantage we just solved for is 6.7. Our efficiency was 0.85. So if you divide the two, you end up with 7.9, and that is your ideal mechanical advantage. And that is the end of that problem.